today we just have 1 hour, maybe less than that. I will quickly go through what we have covered last week, and then if we have time, I think we will have probably, and I will start the history, the development of additive manufacturing, how it started, how it's going, and how it would like be in the near future. And by the way, the videos, the lecture videos are available on YouTube. The links are on ODTÜ class. You can easily watch them once you have free time. But as we mentioned many times, we will be having quizzes in these lectures. So I suggest you attend the lectures and try to do the quizzes. I'm not going in a detailed manner. We discussed these terms, we discussed the democratization of manufacturing, and we said that with the help of additive manufacturing, now everyone has access to manufacturing. It's not that complicated. By doing little investments, you can easily try to fabricate things you have in mind, the things you have designed by using special software. So you can easily start your own business. So in the earlier days, we said that additive manufacturing was mainly used for rapid prototyping purposes, but now these days, we also use them for final products, and even in aerospace industry, people are trying to use the fundamentals, the additive manufacturing techniques to fabricate, to produce some difficult parts. And he said that slicing is highly important in additive manufacturing. You design your part first and then do the slicing. Since additive manufacturing is a layer-based method, you need to put materials on top of each other, layers of materials, and the thickness highly determines the quality of your part. Here we have a thick layer, and this one we have a thin layer, and you see it's much more like to the designed model. But this is a kind of an approximation. So if you want to have high quality products and if your dimension accuracy is highly important for you, then it's better you have lower thicknesses. But the disadvantage is that it will take more time than this left one. And why do we use additive manufacturing? First of all, as I mentioned, in the earlier days, we were using for prototyping, but nowadays it's also used for final products. So that's why people are sometimes using the term digital manufacturing, maybe instead of additive manufacturing. But for prototyping purposes, we use it for checking the form of the products, whether they have the form we are looking for. And we check whether the design part is fitting into somewhere properly, the dimensions are fine or tolerances are fine. And lastly, if it's a kind of an assembly, we are checking whether this moving things are working properly or not. And we said that we have some sub-steps in the design and fabrication pipeline of additive manufacturing. We start with designing the part. We do the conversion to a mesh file. We import them into the CAM software. We do some settings. We transfer this machine file into the additive manufacturing machinery, and then the fabrication is completed. We simply remove the part, and if it's required, we may do some post-processing. We may remove support structures. We may do some coatings. We may do polishing. It's up to your requirements and up to the requirements of the specific additive manufacturing process. And lastly, you can use it as an end product. This was another representation of the process we design, and then we convert into STL file. The original CAD model is 13 MB, but the final one is much higher than that, since we do triangulation, and then we do slicing on the CAM software, complete manufacturing software, and the result of this CAM software is a kind of a G-code file, mostly for FDM and for SLA or other SLS processes. In some of the machines, you cannot easily see the details of the machine file, but they prefer to use binary files, but the interior of them are very similar to the G-code file, since they are defining the movements of the machine, movements of some auxiliary units like turning on the laser, heating up some extruders, moving some specific equipment, and another one moving the laser or extruder head or something. So they simply use G and M codes in their machine files. So this is another representation of the generic AM process. We design, we do triangulation. You see, we triangulate the outer surface. We have the STL file. Then we import it into the CAM software. We do slicing. We generate a G-code file for the motion for the extrusion of material. And then we transfer it to the machine and do the fabrication. We use other terms also for additive manufacturing, like automated fabrication, freeform, solid freeform fabrication, since additive manufacturing gives us high flexibility in terms of the design. You can design any freeforms and fabricate it. It's quite complicated or quite impossible to do it in CNC machining or other complicated manufacturing operations, but in additive manufacturing, we don't have much limitation. We use layer-based manufacturing, we use stereolithography sometimes, or 3D printing, but in our daily life, we prefer to use 3D printing, but in academic life, we prefer to use additive manufacturing. And I said that we don't prefer to these days use rapid prototyping, since it's not anymore a prototyping application. So what are the benefits? As part of the new industrial revolution, digital manufacturing, digital revolution, you can build, you can manufacture what you are designing, what you are seeing. And another important thing, we have reduction in the process steps. If you consider, let's say, injection molding or CNC milling, turning, we have many sub-steps. You need to design according to the many limitations of the conventional manufacturing process, and also you should do lots of modifications in the manufacturing software. You should define the sub-steps. But in additive manufacturing, once your design is ready, then you put it into the CAM software with little setup. Maybe if you don't want to do it, it's also fine. You can simply print your part with default sets, default set of parameters. Another important issue is sustainable. You don't need to, actually, you don't do subtraction of materials, so you don't generate waste. Sometimes you may have little waste due to the support structure, but this is not that much. Another important issue in terms of sustainability is that since we have many additive manufacturing machinery, many 3D printers at home or at offices, you don't need to transport the product from, let's say, one city to another. For instance, if your factory is in Istanbul, by using conventional approaches, you need to fabricate it in Istanbul and then transport it to the Ankara. But in the additive manufacturing, once you have these, let's say, additive manufacturing machinery, you can do it at home, at your offices very easily, and you don't need to use the transportation. This is another sustainability, let's say, consideration in additive manufacturing. There's a nice figure, actually, I didn't show it on Thursday. It's showing the advantages of additive manufacturing. I think they asked this question to many professionals in this field, in the field of additive manufacturing and 3D printing. These are their results. And as you see, half of them said that additive manufacturing has great advantages in terms of complex geometries. As you see here, the biggest advantage. And then here comes the lead time reduction. What do we mean by that? In a moment ago, I said that in the conventional approaches, you need to define many sub-steps. You need to design fixtures. You need to design, if it's an injection molding, you need to design the mold. You need to do some analysis whether your extruded material is flowing to the all cavities in your mold. So this is quite complicated, and you need to spend lots of time on these sub-steps. That's why, as you say, about 40% of the people said that one of the great advantages of additive manufacturing is that you have less time spent for the lead. Another important advantage, cost reduction. if you just consider the material usage, electricity usage, power usage, it's about the same. But if you consider the whole design and fabrication pipeline, you can reduce the same part in a low actually cost. Another advantage is inventory, especially for small batches. If you are producing, let's say, tens or hundreds of products, then again, you don't need to spend too much time, design complicated issues. These are the main advantages. The first row are the major advantages of additive manufacturing. Another thing, engineering redesign. Since we have a large community in additive manufacturing, you can download designs and directly fabricate them on your office, on your printer. So you can easily don't do any new designs and update the available designs. So it's much easier in additive manufacturing. So we also added other advantages, but they're not as important as the first row. What are they? Mass reduction, reduction of assembly steps, obviously. We will discuss all these actually in the upcoming weeks throughout the semester. You can easily fabricate, assemble the whole assembly in a single production. But in the conventional way, you need to fabricate them one by one and then assemble. Another advantage, great advantage, you may have internal channels in your products, but in the, let's consider once again, additive manufacturing, the CNC machining, you cannot have channels inside your parts. This is not impossible actually. You cannot have complicated channels inside a part. Then we have tooling. You need to have special cutting tools, tool for different holes, let's say. With a single extruder or with a single laser, you can complete the whole fabrication. So you can do mass customization. We will talk about it. You have a simple supply chain. It's not that complicated. So you can, another advantage, do a production at a remote, let's say, facility. So these are the main advantages of additive manufacturing, but the first row is the most popular one. But depending on your application, you may also be using one of these in the intermediate or the bottom row. So, okay, there's a compliment from Murat. Thank you, Murat. In the last lecture, we were also discussing AM and CNC machining. I think we spent about 15 minutes just on this slide, so I'm not going to discuss it once more. If you are not actually comfortable for this comparison, please watch the video on YouTube. The comparison between additive manufacturing and CNC machining, we said that additive manufacturing has more advantages, less advantages in terms of materials, since we have a limited set of material, but for CNC, we have huge selection. For the speed, we said that if you just consider the fabrication, CNC is faster, but if you consider the whole design and fabrication pipeline, AM is faster. We simply said that additive manufacturing can produce more complicated products than CNC machining, but the accuracy of AM is less compared to CNC, and you can have any kind of geometry produced in additive manufacturing. And the programming efforts is less in additive manufacturing, but you need to spend more time on programming in the CNC machining. So these were the main comparison topics. We had an example here. We said that it's quite a difficult case for CNC machining. What you need to do is to have special tools, longer tools, if you want to open such a cavity here. And there are sharp corners, undercuts. So another thing, since the machining forces are higher, you need to fix this part firmly from the base. And once you do it, you cannot machine the base. So these are the major problems if you're going to use the CNC machining for the production of the cut. And we had gone through, let's say, a website, and this was your homework, your assignments. You should have gone through this website and see some detailed comparison between additive manufacturing and not only with CNC machine, but also injection molding or other casting operations. So we were stopped right at this point, but not there is not much to talk about here. In additive manufacturing, we also have different technologies which are related to it. First one is the reverse engineering technology. Why is important? And sometimes in companies want to produce the products of rival companies. So that's why they simply use additive manufacturing. What they do, they simply scan the product and then obtain the mesh file and then print this mesh file with the help of their 3D printers or additive manufacturing machinery. Another important technology is obviously the computer engineering, the design, the manufacturing, and the engineering software. Computer engineering software is highly related to additive manufacturing and computer design or 3D printing. They are highly related to each other. Then we have haptic-based CAD systems. Here there is a link, but I don't want to open it right now. There are such haptic-based CAD systems. What they do, they have a kind of a special pen, and with that haptic pen, you can do a kind of a real sculpturing application by using just a pen and a CAD software. These are similar products, and they are somehow related with additive manufacturing and 3D printing. So I'm done with this review, and now I would like to continue with the next chapter.